Imagine a factory where machines are working non-stop. A conveyor belt moves products, a motor turns on, a sensor detects an object, a robotic arm picks it up, then another machine starts working. But here's the question. Who tells all these machines what to do? Meet the Programmable Logic Controller, or PLC.
Welcome to my channel, Science with a Touch of Hugot. Let's explore! Discover short stories and discover ourselves.
A PLC is a specialized computer designed to control machines and automated processes. And today, we're going to understand how this small but powerful device helps make automation possible. What is a PLC? PLC stands for Programmable Logic Controller. Simply put, a PLC is a computer specifically designed to control machines. Unlike an ordinary computer that we use for browsing, gaming, or creating documents, a PLC is built to operate in industrial environments. It receives information from inputs, processes that information according to a program, and then controls outputs. Think of it this way: input, process, output. A sensor detects something. The PLC thinks, okay, something happened. Then it follows the programmed instructions. And finally, it tells a machine what to do. The three basic parts of a PLC. Let's break the PLC down into three important parts. Number 1, inputs. Inputs are the information coming into the PLC. These can come from push buttons, switches, sensors, limit switches, temperature sensors. For example, imagine a conveyor belt. A sensor detects that a box has arrived. That signal becomes an input to the PLC. The PLC now knows, hey, there's a box here. Number 2, the CPU, or Central Processing Unit. This is where the PLC processes the information. The CPU follows the instructions stored in its program. For example, if the sensor detects a box, turn on the motor. So when the sensor sends a signal, the CPU checks the program and makes a decision. It's basically the PLC saying, let me check the rules first. Number 3, outputs. Outputs are the actions controlled by the PLC. These may include motors, lights, valves, buzzers, relays, solenoids. So in our example, the sensor detects the box. The PLC processes the signal. Then the PLC activates the motor, and the conveyor moves. How does a PLC work? Now let's see the basic working cycle of a PLC. A PLC generally works in a continuous cycle. First, read the inputs. The PLC checks the signals coming from sensors and switches. Second, execute the program. The CPU processes the inputs according to the programmed logic. Third, update the outputs. The PLC sends commands to the connected devices. Then, it repeats the process. Read, process, output, again and again. Very quickly. Simple example. Let's imagine an automatic conveyor system. We have 3 components: a sensor, a PLC, and a motor. Here's the logic. If the sensor detects a box, the PLC turns on the motor. When the box reaches another position, the PLC can turn the motor off. This is automation. The machine doesn't need a person to press a button every time. The PLC follows the instructions automatically. PLC and robotics. Where does PLC fit into robotics? A PLC can communicate with and control different parts of an automated system. Example, sensor detects an object. PLC receives the signal. PLC tells a robotic system to perform an action. Robot moves. Then the PLC can receive another signal and continue the sequence. Instead of thinking of a PLC as the robot itself, think of it as one of the controllers coordinating the automation around the robot. In industrial settings, PLCs are commonly used for machine control, conveyors, assembly lines, safety-related control systems, and automated processes. PLC vs microcontroller. Both can receive inputs, process information, and control outputs. They are designed for different purposes. Microcontroller is commonly used in embedded systems, such as small robots, appliances, and electronic projects. PLC is specifically designed for reliable industrial control. So, microcontroller, embedded control. PLC, industrial automation. There are areas where their applications overlap. The important thing is to understand the design purpose. Why are PLCs important? 1. They are reliable. Factories need machines that can operate consistently. 2. They are programmable. If the process changes, the control logic can be modified. 3. They are designed for industrial environments. 4. PLCs make complex automation easier to organize and control. Instead of having a person manually control every step, PLC can coordinate the process automatically. Parang buhay ang PLC. You receive inputs from the world, you process what happens, then you decide what to do next. Hindi lahat ng input kailangan mong sundin. Hindi lahat ng signal kailangan mong pag-react-an agad. You need to process first before you act. Kasi kapag puro input lang at walang processing, baka puro reaction lang ang buhay. When you understand the input, process it properly, and choose the right output, that's when you become more intentional with your actions. Parang PLC. Input, process, output. Hindi lahat ng naririnig mo kailangan mong i-output. Kailangan munang mag-process. Review. Input, process, output. Input. What does the PLC receive? Sensors, switches, and other signals. Process. What does the PLC do? The CPU executes the programmed logic. Output. What does the PLC control? Motors, lights, valves, relays, and other devices. Remember, inputs give information. PLC processes the information. Outputs create action. Programmable Logic Controller may look like just another electronic device. Inside an automated system, it receives information, it processes logic, it controls machines. From conveyor belts to manufacturing systems and industrial robots, PLCs help turn programmed instructions into real-world actions. Remember, a PLC doesn't just control machines, it turns logic into action. That's also a lesson for us. In life, we receive many inputs, problems, opinions, challenges, opportunities. We don't have to react to everything immediately. Pause, process, then act. Just like a PLC, good decisions begin with good processing.
Thank you for learning with me today. Remember, biggest classroom. Don't forget to subscribe for more lessons. Keep finding the Hugot in every day. See you in the next lesson.